પછી તો સાંભળ આ કેમ નાનું આવે છે?
શેરિંગ અહીંયાથી બંધ છે.
શેરિંગ બંધ કર્યું ને?
એક મિનિટ યુટ્યુબમાં જોવાનું આવે. યુટ્યુબમાં ફૂલ
Good morning. So I, Hemant Chauhan, on behalf of CECA Asia and Ahmedabad University, welcome you all to the Day 2 of Composite Industries National Conference and Exhibition 2024. Yesterday, we had a large number of highly fruitful and enriching experiences being shared by the eminent speakers, and today, the journey will continue and will have lot many areas to be covered. The different domains of composites covered by different experts from the different domains of the global applications of composites will be taken up. And in that series, without taking much of your time, I would like to
composite and its classifications, composition in space-borne payload, especially we will discuss in detail. Basic design approach for composite. How to, okay, I will not go much in details, but okay, we will touch upon. Manufacturing and characteristic of composite for the space applications. And the scope of the research for the future, what we have desired and what we are looking for from the academia, industries and our research organization also. So, the Indian satellite system, if you see, we have the variety of satellite for the various purposes, especially for the communication, for the telecommunication, direct to home services, telemedicine, teleeducation, meteorological observation, disaster management, radio networking, and okay, this rescue operations, remote sensing, and scientific studies, just like our Mars mission, Chandrayaan, and so forth. So this is a satellite system. Okay, these are the classifications what we made, what type of satellites we are aiming. I have already explained that communication satellite and Earth observation satellites, small satellites basically for the some identified or some specific purposes. Scientific experiments like Chandrayaan, I already mentioned Chandrayaan, Moon mission, Mars mission, and recently we have launched for the Aditya mission for the solar exploration. And experimental satellite, just like SR yesterday it was talked, how the experimental satellite re-entry experiment was done from ISRO to take the object or to take the satellite from or the spacecraft from the outer space to the our inner and ground. So this is the way satellite communication happens. There is satellite. It is around in the orbit in the Earth, and how there are ground stations. There are the equipments required to make the communications, and you can see. There is a two-way communication. It has to be started. Definitely, all communication need to be passed through gateway. Gateway is where our main systems are there, and then definitely our users. This is the way they communicate, and this is the way our whole system works and establishes the communication between the user and between the service providers. So, taking this into our account, how the composite materials and how this specific kind of approaches will help us to minimize the weight or the mass weight to launch the spacecraft in the orbit, so that we can get the maximum advantage of the cost per se as well as for our the life also. So composite already it is there. What we have mentioned that two or more materials combined on a microscopic level. We are not going for the microscopic analysis because that will need some other classification also. But micro level, which means the two or three, maybe three also, this constituent will be bonded together with the help of some identified processes to get a unique material. That the property of that material will be differently from all the other constituents. And they usually exhibit the best qualities, their constituents, and other some qualities, neither constituent process. Just like that, we are having that resin, fibers, other things, but they don't have, they don't possess the kind of compressive strength. But if they bonded together and they have got that kind of property after the processing, they can exhibit this kind of property also. So the uniqueness of the material Definitely one is reinforcement. We say that fibers or any kind of that, those who are the main load-bearing members, they have been called as reinforcement. Another is definitely matrix. They will bond together, they will protect the reinforced material from the other outer space or the other in environmental conditions also. And matrices that is there. So what composite offers us to, why we have to go for that, and what kind of these advantages we can take in our structures. So you can see here, this is a high specific strength we say, with respect to density especially. So strength the only will not matter here, because we have to have lighter sense also, how it can be, the mass can be reduced. So in that scenario, we have put high sense, specific strength and high specific modulus. Both are required for the purposes of our space. And the action strength, because we have mentioned to, because this will add on the tailoring of this material, so that we can get the desired property for the specific purposes. Corrosion resistance is there. Stability, why we say the dimension stability is very much essential. Yesterday, one thought was there that a kind of optical payloads we have, their dimensional stability very much essential. We are having very much accuracy requirement there for the performance purpose. So that the CT will matter here, coefficient of thermal expansion will matter a lot. Not only CT, here the coefficient of moisture absorption also will matter, because in space definitely moisture will not be there. So kind of property we need here, they should be very much means competent with that environment also. So that ACM will also matter there. And radar transmission effectivity is also requirement, because some kind of protection we have to protect our equipment, so that we used to say that is like red dome or some kind of cover is there. So that should be transparent in that one. And magnet non-magnet is also one important criteria you can have. High impact distance is there. Maintenance cost is low, because we don't have a differential material bonding and all these things we can avoid in different class of adhesive other things, so that we can go for this maintenance. Long time durability, the part consolidation is also there. Small to large part geometry is possible, because we can have different kind of toolings and our methodology for the curing and all these things, so that we can tackle this problem also. And tailored surface finish, design flexibility is there. With the help of various tools and our processes, we can choose this also. So if you see that space-borne payload components basically required, majorly I have classified in 3 domains. That is the first, to meet the structural requirement, second to meet the thermal requirement, and to meet the functional requirement. These are 3 basic classifications. The detailing is also there, but I have just qualified in these 3. So once we call the structural requirements, so definitely high specific strength and stiffness. I mentioned strength and stiffness is required to meet because we have to launch the spacecraft into space. So various components are there. They have been assembled together. So there some specific requirement for the environmental conditions are required, just like the frequency is there. So they should not be in coupled mode. So that if they are coupled, then definitely the resonance can happen. The structure can have some kind of damage or performance degradation. Strength is also in same scenario, that can help us in designing with the safer margins of the requirement for the specific product as well as total stress. If you see the thermal requirement, definitely low CT and high thermal conductivity is required, because definitely their environment is there. So many components or many products what is used in the spacecraft or in satellite, they need some kind of stability in temperature, because otherwise they will not function. So that conductivity will help us to for the thermal management or heat management, so that their functionality can be sustained. As well as low CT coefficient thermal expansion, I mentioned already. Yesterday it was discussed. So that the dimensional accuracy is one aspect, as well as when they have been initially they have been there, so that their effect cannot be translated or cannot be reflected in other equipment also. So their performance and these performance can also be established. So CT will matter a lot, especially for the large hardware like camera structure and other things. This will affect largely. And high electrical conductivity to meet the functional requirement. We are launching some kind of in many satellites where there are reflectors and other equipments where the functionality is one aspect. Functionality means that our waves or microwaves or they have to be traveled in the some component. There the reflect this one electrical conductivity is essential. Without that, they will not function. So that requirement is there. So that if the composite can have that kind of a property, definitely they reflectivity point of view for reflectors up to some certain band of the reflect this one frequency we can use directly CT, because CT offers some kind of property that can be used. But for the higher band of application, definitely some kind of surface improvement is required, where the reflectivity can be improved, electrical conductivity also will be improved, so that they can be used in that scenario, like some kind of metallization or some kind of cladding or something we can do to meet these things. Though these three will guide us to how to select the material and how to select for the specific applications. So again, similarly we have just you can see that how the ceramic metals and polymers we have just taken, how these three can be chosen, so that we can go for the selection of the material for our specific identified product and purposes. So lightweighting, the low density, design flexibility, already we have mentioned these things. But overall composite are highly valued in space industries for their lightweight, high strength, thermal stability and other valuable properties. Their use enables the development of more efficient and capable spacecraft and launch vehicles. Launch vehicle also we are using composite in large amount, and leading to advancement in the space exploration for satellite development also. So definitely, nutshell what we want to convey that composites with the specific other properties and with the selectiveness of this material for the stages of the vehicles as well as spacecraft can offer such very good amount advantages in the our weight saving as well as our payload life also. So that is already classified. Composite reinforcement matrices, metal matrix, ceramic, carbon matrix, and polymer in thermoplastic and thermostatic. Also we have some discussion on. But especially in space, we are mostly using our thermosets, because the space the property should not be changed with the environmental conditions. Again, that classification we have put metal matrix, composite, ceramics, and polymer matrix. That our reinforcement, this class of the reinforcement are required, and metals and polymers and ceramics, this kind of matrices we can use for different kind of product development, namely that EMC and CNC and this MMC. So a type of reinforcement we have mentioned here, that we are using unidirectional fibers, some kind of continuous fiber, some kind of this soft fibers, biaxial this one fabrics can be used for the different purposes, and they can be tailored for the multi-axial what we have explained there. And random fiber also, because if you want to have some kind of isotopic property, so we can choose random fibers, and they can be mixed with resin and cured for the applications. And this knitting is also there in because the fibers can be knit together in differential axes, so that the properties can be taken. The advantage of the fiber properties can be taken in the particular direction. One specific application means process is braiding. Braiding, there you can see that the three axes yarns can be placed in a single plane. We'll say there the different axis fibers can be put, and then we can take the advantage of the axial as well as this one braided direction fiber, because definitely that fiber only will exhibit the property that only we can utilize, so that will give the advantage in the particular direction in a single plane. So configuration wise we have given that we have extended here, that fiber reinforcement composites, particle composite, clay composites, laminated composites, sandwich composite, and combined composites means we can have both kind of combinations, so that we can tailor some kind of requirement. That also we have done here. Okay, this is again. So now we'll come to the space structures. So we see that we have the in space what we are launching, so that we have launch vehicle or rocket, what we say, spacecraft or satellite, payload transponder, antenna, camera, etc. These are the main three domains where we are dealing in our space this program. So if you see the launch vehicle, this is a 3-stage vehicle. This is a GSLV Mark 3, the third generation launch vehicle. So if you see, that is a 3 stages. We have the basically in our lower stage, that is our motor, that is our means water cases and some kind of propulsion stages are there. And second stage also definitely cryo stage, that is also for propulsion purpose. And the last stage, that is our payload, where the payload and other scientific instruments are there. So if you see that each and every stage that composites are there, I am mainly classified. Just kind of you see that this strap-on nozzles are there. There is a boosters is there. So booster also motor cases are there. That also high amount of composites are essential to reduce the masses. Second stage also composites are required for just like propulsion tank, propellant tank, pressure tank, where that we can use. Spacecraft also many space. I will come to the next slide where the space satellite spacecraft we are using that composite material. But mainly if you see the stage wise, if you reduce the mass, how much advantage we are getting in the payload, that will determine the selection of the material. I was mentioning the selection, how to select it. We cannot use everywhere composite in space because that will have their own benefits and this one. So what we see, if we go for the first stage reduction of the mass, advantage of the higher stage or the final stage is 1/4 terminology, if you say. Second stage 1 by 3, third stage 1/4, and the final stage total. So once 1 kg mass is saved in this one, only 0.25 kg mass will be added in the payload. So we have to choose judiciously that where the reduction is required. So what we do, we say that third stage and fourth stage maximum amount of the composite we wanted to use, so that we can get the direct advantage in the payload. Payload mass saving will definitely lower the cost of launching, as well as it will improve the life of the spacecraft satellite. So that advantage we have to take. So that's why we are choosing here. And you see the equipment in the third stage and fourth stage, equipment routes are there, payload fairing, the 5-meter payload fairing is there. So a very huge amount of mass saving is there in that stage also. And that will directly benefit our payload, payload gain. And liquid stage and other stages, because of specific application where that high temperature and other things required, there we are using a composite in lower stage also. So it's not only the essential, we can use third or fourth stage also, where the requirement and the application is essential, we are using. And if you see spacecraft or satellite, where we can go for the composite especially, if you see the reflectors, we have the waveguides, we have the feed horns, we have brackets, we have other this one essential parts with the spacecraft required. So I will go for these three basically. If you see one kind of this one feed bracket was there one feed horn was shown. That's the horn was there liner, one aluminum liner we have placed. Why we have placed the liner? Because that is the requirement for our functionality purpose. That was only because if you can meet the requirement with this kind of composite material itself, so we need not to go for the metallization and other thing. So this is the one challenge where the material can have the kind of reflectivity or kind of electrical properties, so that they can be chosen. This is very huge amount of this one feeds and other waveguides are required for the space, our payloads, so that if there we can have that improved property, definitely a lot of thing can be changed and very huge amount of mass can be saved. Secondly, that this one, our reflector also I mentioned, so specific and applications just like KU band and below. We can go for directly this CFRP, but if you want to go for higher version, K, Ka and above, so definitely that functionality of the reflector to be improved, especially for the electrical properties. So there the coating or some kind of metallization essential for the surface. We are doing here some coating we are doing and some kind of cladding we are doing. But what we wanted that definitely these two processes are adding. So that can be reduced here, and then if the material itself can exhibit the property, we can go for directly for the composite itself. And these are the parts in various kind of satellite, like our Earth observation satellite or optical satellite, as well as communication satellite. Many parts we have shown, like our antennas are there, some kind of solar panels are there, some main structure there, propellant tanks. The propellant tank also, there is a composite, because that you can see the inside that propellant tank, the huge size tankage are required. That we are going for the metallic, because definitely we have to store at high temperature, pressure, so that permeability of the material is one aspect. So we can have if you go for some kind of material, those can take that property, that requirement, so very huge amount of mass saving can be done, because they are the main mass. Okay. So composite material in satellite, what we see, I have just, these are the realized hardware we have taken from the internet. If you can see here, this is the mainframe structure. So this is structure where all the satellite component will be assembled around this hardware. So that you see this kind of huge structure we are going for the composite because we have to save the mass. And we have to take the advantage of the tailorability other things so that this requirement in space can be met. If this is a I3K, I4K, I6K class of satellite is there, where that size, shape and size will be enhancing so that in the similar ratio you can save the masses also. So you can see the usage of composite material in the mainframe structures. Here you can see that reflectors already I have mentioned. That reflector also we are in a large amount of composite materials are being utilized. Thirdly, you can see the pressure tank. That is pressure or propellant tank we are using. Here also that we are storing gases at very, very high pressure so that they can be utilized in the space for propulsion purposes. But you can see here that is a filament winding process is there where that inside one liner is there. That is a very thin liner is there. Over that this reinforcement is being overlaid for the purposes. What here advantage we can take from the composite, we can have that kind of material, though the liner can be extracted, so that mass of the metal can be reduced. That one aspect, already I mentioned in the propellant tank, very huge amount of mass saving is there. Okay, how the structures we have evolved in space purposes, just like this, our monocoque structure are there, semi-stiffened structure are there, corrugated structure are there, and honeycomb sandwich cells are there. So these are the classification, and with the various purposes we are choosing based on the requirement. Just like that for you see, sorry. If you see this kind of hat-shaped structure where the compressive loads are there. I mentioned the third stage or in that third or fourth stage of the spacecraft where the payload raptors are there and the equipment base is there. Their compressive loads are very high in the requirement. There we can use this kind of shape structure. And where that only stiffness and other requirements are there, we can go for the honeycomb, this one, cell purposes, sandwich cell also. So we have to choose based on the requirement this kind of structure configuration with the composite to save the mass and to fulfill our purpose. Okay. So space-borne structure already, because we have come to the structure part. So there is we have to provide the platform to support the kind of equipment or kind of the payload we have to carry there. Integrity purpose we have to get together for the final satellite purposes. And mechanical load bearing, definitely that component will be loaded and they will be subjected in the different environment. For that purpose also we have requirement. Electrical and thermal conductivity path also we have to provide for the this one. Primary structure, secondary structure and tertiary structure we have classified in 3 domains. Where that the primary structure they are main load bearing members. They should not affect anything on secondary or tertiary hardwares. So that they have the just like you have seen the mainframe structure, they are the primary for the spacecraft. So their choosing of material with the strength, with the modulus purposes is essential here. Secondary structure basically to decouple with the primary structure, so that only stiffness and some kind of distance requirement is there. So we can choose in between what kind of material we have to select and what kind of configuration we have to go for the structures. And tertiary definitely they have been only for our purposes, functional purposes we are going. Definitely the requirement is there, but that is not in line with the primary and secondary. So once we are going for the monocoque we have told and had a separate structure we have told. But third was the sandwich structure. Sandwich structures are mostly used in the spacecraft structures because they can be utilized basically for their bending property. Other thing they can help us for selection of this material to get the stiffness as well as load bearing capability also. And you can see this kind of cores and this kind of rigid core, flex core, or overextended core, corrugated core. These 3 types of cores are required for selection of shape. And just like that, if you have the reflector, so we can not go for the rigid core, we can go only for the flex core. So this kind of core selection is essential to get the desired property of this stiffened structure or sandwich structure. So how the core is manufactured, that also we have explained here. You can see that that is a hob is there. You can see the hob they can cut and they can be expanded. So there is a process is there, and second process is corrugated core. So they can be stacked together and then can be sliced. The two methods is there. Basically, we are going for the first one, standard one. And you can see that last one is the flex core. The flex core, you can see the cell configuration. They can, because this configuration, they can take the shape of that our mold or what kind of a tool is there for the required purpose. So, category of advanced composite we have categorized in these three, basically four main parts. The structural composite, filament bound composite, ablative composite, thermostructural composites. Structural parts, I mentioned that sandwich, corrugated structures, and as well as this different structures are there. Filament bound basically used for the kind of pressure washer motor cases where that axisymmetric object, this product can be bounded and can be used for the application. Ablative where the high thermal heat or other thing is required, the ability you are using. Thermostructural component where both can be together, just like in our camera structure where our dimension stability as well as our this one structural requirement there both we can select for the application. So we are basically going for the structural sandwich and filament bound and this one for the monocoque for the this one thermostructural composites. Okay, the feature of composite manufacturing process, the material and the products made in single operation that because we are going together. The manufacturing process not only involves physical changes of the consequent but also at the chemical reaction at the time of processing. The process must ensure completion of chemical reaction, physical changes and creation of correct material and structure. No physical or chemical damage to the fiber due to the processing process temperature and pressure because that also will come in next one. No warts, blisters or cracks in the matrix and no fiber breakage. In metal, the in-orbit properties cannot be changed during the fabrication of structure. However, the composite material is formed at the same time as the product or component or structure is being fabricated. It means that the process plays a vital role of determining the performance of this resultant structure. So, steps involved in manufacturing of composite is pre-processing, processing, and post-processing. So, these three stages we can determine. Or we can have that how the material can be pre-processed and post-processed, and after the post-processing we can have the material for the use. If you can see the pre-processing, that we can have the layup, we can have the pre-pack, or we can have the different kind of material what to be taken for the curing. So in the curing we can select the process. Here what we have taken, that is out of autoclave curing is there, that like after this one molding and curing is there. So in that we have to go for the mold in the vacuum bag condition for the curing, and this kind of cycle or this is we have taken for some specific thing, but we can have a different kind of matrices for and accordingly that we can choose the cycle. So composite layer technique, you can see that wet layer or hand layer is there, vacuum bag molding is there, autoclave molding is there, filament winding is there, pultrusion, region transfer molding is there, relation of sandwich composite is there, press molding is there, and autoclave molding and tape binding. These kind of processes we are using for the relation of product for the differential purposes. So this is the hand layer. You can see that there is a mold, there is a kind of this our wet rag is there. They can be laid in the derived orientation, and you can see the shaping, and they can be put together, and they can be consolidated, and then we can apply the heat for the curing. This is the vacuum bag molding is there. In the vacuum bag molding, that mold is there, and over that our composite laminate or stacking we can do, and we can have the vent housing also, vacuum where that we can take the outgassing outside during the curing also, and they can be cured together, and we can get the desired product. You can see the curing cycle is there, and at what stage we have to stop and what stage we have to cure, and we have to release the vacuum so that the final product can be get without any distortion. So this is the cycle we have to use for the vacuum bagging curing. This is the procedure we are following for that. There is a various this one consumables are there, like vacuum bagging films, release film, other things are there. So these can be taken, and then this product can be realized. So in the extension of this one, this is autoclave molding in there. Autoclave molding it is similar to the vacuum bag curing. Only thing that inside also some kind of additional pressure we can apply. so that the compaction can be improved and the better property extraction can be achieved for the material is being used. This is the curing cycle for the autoclave. There the pressure and other thing has to be synchronized together so that the property or the this material can be cured in a required manner. So you can see where the pressure is there and where the vacuum we can apply and we can reduce so that the product can be cured properly in this autoclave. And this is the filament. Filament also, this is uniqueness of the process is there. This is the CNC based process. So totally automated one. And here the only thing is there that we are dealing with the fiber directly. So that the fiber placement over the mandrel, you can see the mandrel. That mandrel is a cylinder dome tank is there. The cylinder and this dome together have been bonded so that we can enlarge that means our shape of the this one tank. Only thing is what uniqueness in this process is that you can see the fiber we are dealing directly so that we can utilize this maximum property of the fiber here. Otherwise, everywhere we are manually placing the fiber, so definitely that some kind of error in the placement of the fiber is happening, and we are not getting that kind of maximum property out of the material. But this is a process we can get. But limitation in this process is there. We can have only like axis symmetric object we can bond. Otherwise, this kind of shape or reflector or some kind of waveguide or you have mentioned there or structures, we cannot go for this one. Here one more uniqueness I will tell this inside the liner. That metal liner is there, but once you are pressurizing that, because very thin liner is there, I think 0.4, 0.5 thin is there. Once you pressurize it, it will go in plastic stage. So the plastic stage with the help of composite, we can use in elastic manner. This is the unique process is there that we know this is autofiltration, where it can go plastic stage and once it come back, the composite will play the role to make it elastic in nature. That also very unique property is there in these tanks. But what I was willing here to say that if you reduce that liner also, so very significant mass you can reduce. Because the property of the matrix is not sufficient to take that kind of pressure. But I am going through with the literature that so many experiments is being done by some NASA also I have read. They are going for the direct composite for this kind of high pressure application in filament product also. And this is pultrusion, this is regular process you are using. Okay, the lines of studies already we mentioned. Tooling in composite, tooling is very important to select because we have to go for the curing and we have to go for the product with lesser dimensional or lesser inaccuracy in the product. So we have to, because I have given this and time is not there to explain. So we can choose based on your application, based on your materials. And machining of the composite, this is tricky because we are not going for any kind of this one couplant or this one kind of, so that the machining and their parameter to be chosen so that the damage should not be translated in the final product. The defects, these are various defects is there and there what the effect of this defect is there that also we mentioned. So that we have to go for the very serious things, so if some kind of defect is there so that health monitoring of the product is very essential so that we cannot have the problem at the end of the time. So this engineering method is there. So what type of entity and we can choose based on the available tools. Testing is very important aspect, characterization for the material and for the product also. So with the starting itself from the material per se, we have to go for the full characterization and that values and that kind of material property also only to be taken for the our design and analysis purposes. These are the procedures and these are the test requirements are there. These are preparation of samples we have told. Quality control is very high essential in the composites because without this monitoring and because of this regard purpose, this quality control, if they are not there, then definitely some kind of misinformation for the product and that can lead for the further problem in the product qualification and testing. Scope of the research in the field of composite, what we are looking here, study on more emphasis on the development of flexible high strain tolerant drilling system that is required to go for the large antenna or large shape component for the space And this one 3D woven fabric, we are essential that we can have line of fabric that have the 3-directional properties so that we can utilize in a single layered one. Develop of CNT is also there. Improve and thermal conductivity and electrical conductivity is essential. Guarantee you investment there. And 3D printing on composite material. Because already we are there in a additive manufacturing zone, so that composite also can be 3D printed, so that we can get this advantage. Thank you all. Any question is there? You can.
Any questions?
Yeah. Yeah. Slide number? Oh. Ah. Which one? Carbon fiber.
Epoxy or Q&A ester. Epoxy left bottom. Carbon fiber oblique.
This one, the primary test, that is some correction is there that we have taken the image from the net. This is epoxy base or cyanide ester base. Why cyanide ester is required? Because epoxy is having some kind of moisture absorption is more in epoxy. But cyanide ester is less moisture absorption. So that when we are going to space, so CME have mentioned, CME property can be utilized for this specific resin system. So that where the dimensional stable structure are required, where they like camera structure other things, there this kind of material is essential. And ester matrices. This is not cyanide is there, but some spelling correction is there.
Yeah, please.
Yeah. You mentioned you are using the honeycomb structure.
Yes, yes.
So how you make sure the honeycomb structure's holes are not poured with the resin, so the resin goes.
Resin is not poured in the
And the
cell
holes
of the hole.
cell of the.
That's why if you see, because we are not go for any detail in that process. If you see the honeycomb structure, we are putting that honeycomb core is there. Over that, two methods is there. That is a co-curing and that is a single curing. In that, we have to go for the pre-cured sheets are there. It can be for metal also. So that we are applying that one over the adhesive. You have to put the adhesive also, and then you can put the sheet and cure it. So the adhesive is very thin in the maybe 80 to 100 micron only. So that you see the cell of that core, there they will form the meniscus. That will generate the bond. So they will not go in the hole, they will just form the meniscus itself and they can bond with your seed. And one more process yesterday our colleague was explaining, that is our reticulation. You can see the very high or very large kind of shape of there you can reduce that cell adhesive also. That is process reticulation. So that mask, because that is dead mass only, it is not going to help in bonding. It will just lie on your skin. But we want the bond to be generated within the cell of the honeycomb and your seed. That is sufficient to take. It is
So
not
what type of material you are using for?
You can use for the metal also, you can use CFRP, KFRP or anything, quartz, anything. That can be means compatible with your adhesive. You cannot go for the differential, this one prepeg or this kind of reinforcement and different kind of adhesive. They should be compatible together and their curing cycle should be compatible with each other, so they can generate the bond with your core. Core itself can be based on metal or non-metallic. So we are using Nomex core, Kevlar core people are using. We have developed here a carbon core also. Here inside.
Did you try any lightweight non-woven fabric for that?
Only thing you have to choose based on your application. It is not everywhere we can go for the honeycomb only. I have mentioned there is only you are using monocoque only. With the different structure where the compressive loads are required. Like payload adapters are there, EB shrouds are there, equipment base is there. But we have to choose this application. But these can offer in differential domain, differential property. But we have to combine them or we can choose differentially so that we can get the maximum property out of material. It is tailor-made property. No? Only CT cannot help us in a single fabric only. We have to, or fiber. We have to tailor it accordingly. We have to put the layer sequences. I will not run in detail for design. Tailoring the material in the design direction orientation so that we can extract the third property or the resultant property close to the requirement. So the component what best offers us is tailoring. Based on our need, we you see the pressure water, we can have differential material. We cannot go for the hoop and meridian similar. So that is tailoring, that you can use. Anything else?
Which method are you using for this component for space application especially? Because there are so many methods for that.
Yeah.
But,
So I will just name it where I am working here in SAC ISRO AHMEDABAD. We are using sandwich configuration for autoclave as well as this one out of autoclave, like vacuum and curing. There are filament binding is widely used in our other centers for the motor cases, for the piston tank and other applications and other things. So based on the application, we are using the process.
I think there are a lot many questions from Mr. Prashant Kumar. So people may enjoy his company during the tea time now. May I thank you, Mr. Prashant Kumar, for such a complete course on composite material.